Okay, this is the test review for Module 2. And what I've done is I have taken one of the practice exams. I just clicked on the practice exam assignment. It randomly chose some questions for me, and then I printed it out. So I have it here on paper to work out with you guys. So let's go through these problems and see how to do this practice exam as a warm-up for the test. All right, problem number 1, rectangle J prime, K prime, L prime, M prime, shown on the grid, and that's right here, J, K, L, M prime, is the image of rectangle J, K, L, M after transformation. So this is the image. We call this a pre-image. It's a pre-image if it was before the transformation. So once it says the same transformation will be applied to this trapezoid, STUV. And the question says, what will be the location of T prime? So this is T right here. Where will T prime end up if we use the same transformation that was done here on this trapezoid? So first we have to figure out what was done. Okay. J is in the same spot. There's J and J prime, M, M prime, L, L prime. So everything's in the same spot. So it's not a reflection. A reflection would reverse it to where now J would be on the outside and still on the left. So it would go to the right if it was a reflection. If there's a rotation, it'd be upside down. So this is obviously just a translation. It was just here and just slid over here. So let's find out what kind of translation it was. Let's look at point J. J was at -7, -6. Okay, that is the point of J. J prime is at 6 and -9. So what transformation was done? So obviously it used to be XY, and what happened was the X went from -7 to +6. Well, 6 minus -7 means you add. So it's the same as 6 plus 7, 13. So this is a X plus 13. And the Y went from -6 to -9, which means the Y subtracted 3 more. So the rule is X plus 13, Y minus 3. So what is the location of T? T is at 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. It's at 5, 5. So applying this transformation to 5, 5, 5 plus 13 should put us at 18. 5 minus 3 should put us at 2. Let's see if that's one of our choices. Hey there, 18, 2. So that should be the location of T prime after the same translation was done on the rectangle. So, all right, problem 2. Triangle HAM is translated using this rule. XY equals X plus 6Y to create triangle HAM prime. If a line segment is drawn from point H to point H prime and from point A to A prime, which statement would best describe the line segment? So let's just, for visual purposes, let's say we've got HAM, okay? And we translate it +6, so it just moves straight to the right. All right, so we have the same triangle. It's H prime, A prime, M prime. So just so you can visualize what's happening here. It said if we drew a line segment from point H to H prime, okay, so let's do that. If we drew a line segment from H to H prime, there's H, and from A prime to A, what would be true? They share the same midpoints. Is that true? No, the midpoint of this line segment would be somewhere around here, and this would be somewhere around here. It's not the same midpoint. They're two different places. They're parallel and congruent. Parallel, this should have a length of 6 because we added 6, right? And this should have a length of 6. They should be parallel because they all move the same direction. This should be true. We'll check this. They are diameters of concentric circles. There's no circles or anything to worry about there. They are perpendicular to each other. No, perpendicular meet at 90-degree angles. That's perpendicular. These are parallel. So our answer is number 2. If it helps you on this, get you some paper and draw that like we did. We just drew what it was saying to do. Okay, which transformation will map figure H onto figure H prime. So let's get the little H prime. So if we start with this one, how can we get this one? All right, reflection across the y-axis. This is the y. So that would put it over here if we reflected across the y. So that's not it. Vertical translation of 10 units, a vertical translation of 15 units. Verticals up and down. So possibly one of those, or reflection across the x-axis. Reflection, put it down here. But is this a reflection of the x-axis? Let's look at that. This is this point and this point. If that's a reflection of the x, those should be the same distance from x, because the reflection be 1, 2, and this one's a 1, 2, 3. So this is a distance of 2, and that's a distance of 3 from the x-axis. So that cannot be a reflection because it moved farther away after it moved down here. So that is not a reflection. It could be a reflection over like y equals -1/2, because it'd be 2.5 and 2.5 away, but that's not one of our choices. So it's not a reflection of that. So it is a vertical translation. We would know for sure if they had labeled it and said this was like A, B, C, and this was A prime, B prime. The fact that the A is on top both times, we'd know it's not a reflection, because that would move the A on bottom. So A prime, B prime. So how far is it translating this? Is it going 10 or 15? Well, to know, you have to look at the same point in both shapes. So let's look at the A and the A prime. So those are the same shape. So the A goes down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then it gets to the A prime. So this is a vertical translation down 10 units. The A went down 10. The B went down 10. All these other points, they all went down 10. So that's how we figured that out. All right, let's look at the next part. So let's look at number 4. It says rectangle ABCD reflected over the y-axis. A, B, C, D. They have to be in order. A, B. We don't say A, C, B, D. In order in there. What rule shows the input and output of the reflection? And what's the new coordinates of A? So it wants to know this one. Where does it end up? So over the y-axis, this is the y. This is the x. Reflect of x. And sometimes it has us reflect over the line y equals x. Where's that line? Well, if you have your graph, y equals x includes the points 0, 0, 1, 1, 2, 2, 3, 3, -1, -2. That's the line y equals 0. So if you have to reflect over the line y equals 0, you're reflecting like that way. All right. So you would reflect down. So y equals x is a diagonal line. But we're over the y-axis. So I'll take this this study paper here to illustrate. I'm going to moving my shape around. All right, and we're wanting to know where A prime is. So I'm going to mark A so we can keep track of that. So reflecting over the y-axis. This away from y, so it should have 1 unit away over there when we reflect. So when we reflect it, that's going to end up there now. So that's 1 unit away that direction. And A prime ends up way over here. So the rule that we're seeing is XY becomes, well, let's see, what did D came? D moved over here. C moved over here. This was -1, 1. This is 1, 1. This is -1, 3. This is 1, 3. So what's happened is the x is just -x, and the y is staying the same, 1 to 1, 3 to 3. So that's our rule that we're looking for. So if that's the rule, this is -5, 1. So over here, this would have to be 5, 1, because it just changes the sign. So right here's our option. XY becomes -xy. A prime is at 5, 1. All right. That's how that's going to work. Pull 2 off there. Let's look at number 5. All right, which set of reflections would carry a parallelogram ABCD onto itself? Okay, and this has some of that y equals x stuff, which again is, it's a diagonal line. It's a diagonal line. So let me illustrate this. So if you can't do it in your head. Little parallelogram the size. Cut it out. You can just play with a little parallelogram. All right. So x-axis down here. So now it's kind of overlapping the y equals x. Y equals x is next. So this would reflect for everything on this side to move over here. So it would reflect kind of like that. Then the y-axis, we go back up here, and then the x-axis. So that ends up right there. Can't be this one. How about the x-axis, the y-axis, the x-axis? So if we go over, let me turn it right. The x-axis, the y-axis, and the x-axis. That does not end up back on top of itself. Not that one. How about the y-axis, the x-axis, the y-axis, the x-axis? Okay, the y-axis, the x-axis, then the y-axis, and then the x-axis. Hey, that one does it. So we don't even have to check the last one, but it's one of those y equals x, so it would reflect over here first, and then the x-axis and the x-axis. So it ended up down there. Okay, moving right along. The triangle STU, there's STU on the coordinate grid, is reflected once to map onto STU prime. If vertex T, okay, there's the original T, so T prime is at 2, -2. 2, -2. So we're saying T prime ends up right there. That's T prime. The coordinates of S. So obviously it reflected over the x-axis because T is 1, 2 above it. This is 1, 2 below it. So it looks like it was reflected. So S would reflect below the x-axis too. It's 1, 2, 3, 4, 5, 6. See, it's at 6. So it would be -6. And nothing would change about the left and right. So reflected over the x-axis. So this would be at the point 8, -6. Right there. And of course, that U would reflect right there, and that would be the triangle. I made it a little skinny. I missed my mark there, but it just reflects over the x-axis. Okay, number 7, kite. Here's kite ABCD, and it's rotated 180 degrees clockwise around the origin, and then reflected over the y-axis, and then reflected over the x-axis. So where does A end up after all of that mess? Well, let's see. All right, I'm gonna trace again for you visual folks. You don't have to have a visual copy. You can do it just in your head. So it's rotated 180 degrees around the origin. So this point right here is on the x-axis. It'll still be on the x-axis, but it'll rotate around and it'll be over here. See, because it's 180 degrees. This point went 180 degrees. Every point goes half a circle around this origin. Okay, then it's reflected over the y-axis. So the y-axis is right here. So this would go right over here. And see, that's back on top of itself there. And followed by reflection over the x-axis. Okay, now we're going to reflect it up over the x-axis, which means D doesn't move because it's on the x-axis. And look, everything's right back where it started at. So the location of point A after the transformations, it's at -5, 1. -5, 1 right there, back right where it started. Right where it started. All right, fabulous. Let's look at number 8. Okay, EFGH represents a trapezoidal plate at its starting position on a rotating surface. So it tells us this rotates. The plate is rotated 9 degrees and counterclockwise. So counterclockwise is, that way. And if the rotated trapezoid, what are the coordinates of the endpoints of the side point congruent to EF? Okay, so here is EF. That's the 2 original. And it wants to know, after that's rotated 90 degrees, what is the coordinates of the E and F prime, right? So if we have, I've got a little paper here to draw on this. If I have that, all right, there it is. I got it drawn. If it rotates around the origin, that means it's going to move down to where it's going to be 90 degrees this way. Okay, like that. So we're looking at these 2 points out here. Well, let's see what the rule was. What happens with that? When this rotates, So this point here is at, G is at -4, 3. All right, when it rotates down here, after it does that, it rotates down here, then it's going to be at -3, -4. Because our rule, counterclockwise, 90 degrees, our rule is for XY, what will happen is they will trade places, 4, 3, 3, 4. So it'll be YX, but this was -4, that's -4, this is 3, it's -3. The Y changes signs. So that's the rule for counterclockwise 9 degrees. Hey guys, you can use notes on these tests, right? You can have all the handwritten notes you want. So I would write all these rules down. They're in the lessons. Go back and write, what's the rule for 9 degrees counterclockwise? All right, I'm gonna write that down. What's the rule for 9 degrees clockwise? What's the rule for 180 degrees? Write these rules down. And then when you have the test, okay, here it is. I know what I'm looking for. Quick and easy. Take advantage of it, guys. Take advantage of it. So E starts out at -4, 8, which using a rule means the Y is going to change to the front and become negative. It's going to be at -8, -4. Okay, so it's going to be one of these two. F is at -7, 5. So it's going to be at -5, -7. Ah, there we go. There is our answer. All right. Doing well. We're over halfway through. All right. This grid shows figure Q in its image. Figure Q prime, its image. Image, pre-image, right? After transformation. What transformation was applied to figure Q? How did it get down here? Okay. So rotation, 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 rotation. It was obviously a rotation somehow. So was it a counterclock rotation of 90 degrees? Remember, counterclockwise, 90 degrees is going right there. So if it's this way, it would be this way. Now I would put it over here somewhere. How about a clockwise rotation of 180 degrees? That's halfway around the circle. It's going to be down here somewhere. Counterclockwise rotation of 270 degrees around the origin, or a clockwise of 270. So 270 is, let's see, just think about it. If you're starting here, 90, 180, 270. Or clockwise, right? So if it goes 90, 180, 270. Bingo, counterclockwise, going counterclockwise. That gets us right where we want to be. Clockwise would go 90, 180, it'd be back over here. So it's not clockwise 270. So this is the same as a clockwise 90 or a counterclockwise 270. They end up in the same place. So they would have the same rule if you're writing rules in your notes. All right, and let's look at number 10 here. Peter reflected parallelogram ABCD across the y-axis. No diagram, they're just talking. If angle A is 115, so in that parallelogram, the angle for A is 115 and B is 65, what is the degree measurement of angle A prime? Okay, so this is a conceptual thing. We can draw it if we want to. We can make up our own ABCD, but there's no need to do that. It's just asking if angle A is 115, what's angle A prime? Well, if you pay attention to these that we've done, this is the rotation. We've done reflections, we've done translations. In all three of those cases, this shape stays exactly the same. It just changes position, but it's the same size. All the sides are the same length. It's the same shape. That doesn't change. So if the side links don't change, the shape of it doesn't change, that means the angles don't change. This angle is still the same as this angle, even though it's rotated. This angle is still the same as this angle, right? Even though it's rotated. Those do not change. So if A is 115, then A prime has to be 115. It's just how it works. Just how it works. So, hey, almost done. If triangle ABC is congruent to triangle DEF, which statement is not true? Okay, let's talk about this. I'm just going to draw it just so we have it. I'm going to make them the same, as close as I can. So if we say ABC and DEF, and I have to number them, I have to label them in exactly the same order. because it says A, B, C is equal to D, E, F. That means A and D are the same. They're the same point in the same location. I can't say this is A and then switch and say D is over here. A is the same as D, B is the same as E, and C is the same as F. All right, those points all in order in two triangles that are congruent. The order means something. That means those points are congruent. A is congruent to D. So let's see what it says. It says AB is congruent to D. What's the which one? Don't let this fool you. I'll highlight that. AB is congruent to DE. This is AB. This is DE. Those should absolutely be congruent because, as we learned, if they're congruent triangles, everything should be the same. So that's the same. Angle C is the same as angle E, congruent. Angle C is right here. That's this angle. And it says it's congruent to angle E. We don't know that because C should be the same as F. And those don't, we have no way to know those are the same. So that doesn't look right. BC and EF. BC is this one back here. EF is that one. Those should absolutely be the same. Notice I'm marking it with 2 marks and this one with 1 mark. Because if I put 1 mark here also, that would say these two are the same. These two are not the same. This one's the same as this one, this is the same as this. I have to mark them differently. But that is the same. And angle A is the same as angle D. Angle A is the same as angle D. And that's absolutely true. So this is the one that's not true. True. All right, last problem. Triangle ABC has been translated. Okay, translated means it was just, moved some direction, but not anything else changed. Just translated. To create triangle A prime, B prime, C prime, angles C and C prime are both 32 degrees. That's right, it should be, right? If that's 32, that should be 30. Angles B and B prime are both 72 degrees. So let's draw this real quick. All right, so I'm gonna label this A, B, and C, and then I'm gonna try to draw the same triangle over here. A prime, B prime, C prime. So it says these angles are the same. So I'm gonna label that C and C prime. They're both 32 degrees. E and B prime are both the same. So I'm going to mark those with 2 marks. But those are the same. And it says sides BC and BC prime are both 5 units. BC is 5. BC prime is also 5. Which postulate or theorem below would prove the two triangles? Oh, is this side, 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 angle, side, angle, or hypotenuse leg? All right, well, remember, hypotenuse leg only works if you have a 90-degree angle. We do not have a 90-degree angle. We have a 72 and a 32, and so our last angle is smaller than, because a triangle has to add up to 180, and these already add up to over 100, so we know it's less than 80. So we do not have a right triangle. It cannot be HL. Side, 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 okay? Did we prove all 3 sides are the same length in our triangles? No, we only looked at one side. We did not show that all 3 sides are the same length. So this is not side, side, side congruency. So that leaves side, angle, side, and angle, side, angle. We proved angle B is the same because they told us there, and angle C are the same, and the side that's in between them. Angle, side, angle. Angle, side, angle. Notice in the middle is the word side, and that side is in the middle of the 2 angles. It has to be in that order. In that order. It can't be an angle, and this side. Angle, angle. This side is not angle, side, angle. Angle, side, angle. There's the 2 angles, sides in between. There's the 2 angles, sides in between. Side, angle, side would mean maybe we knew this side was the same in both of them, and we didn't know B. So we would say side, angle, side, because the side is right there with the angle in the middle. So that's why we need that. But it's angle, side, angle. So hopefully this helps. Test is due by Sunday. There should be problems very, very similar to this. You can go back and review any parts of this. If any of this is confusing, please email me.